let's try to put what we're getting ready to talk about in context for a moment. Let's see a little brighter, maybe. This is an equation. We know how to solve it. The reason that we know how to solve it is because it's a linear equation. Do you remember back in chapter 2 we talked about a linear equation is first degree? The x is being raised to the first power in a linear equation. The strategy for solving a linear equation was put your x's on one side, put the constants on the other. So to do that, we could get rid of the 5 by subtracting 5 on both sides. Get 2x equal to 7. And divide by 2. And get x equal to 7/2. Linear equation. But I told you when we solved those, there would be other kinds of equations by the end of the semester that we'd learn how to solve. Later in chapter 2, we solved absolute value equations. And before the semester's over, we're going to learn how to solve 3 more types of equations. Today, we're going to look at how to solve another type of equation, and we're not only going to look at it today, we're actually going to look at it next time as well. We're going to look at how to solve what's called a quadratic equation. You say, well, what's the difference? Well, a quadratic equation is not first degree. A quadratic equation is second degree. The biggest power on the variable now is going to be 2 instead of 1. The definition of a quadratic equation actually goes like this. It's any equation that can be written as. Now, it doesn't mean it has to be written this way, it just means it can be written this way. Something times x squared plus something times x plus something is equal to 0. Now, there's a little bit more to the definition. I don't want to get real bogged down in this first part. A, B, and C by definition are real numbers. Well, almost everything in this class has been a real number, so that's no big deal. But here's another part of the definition that is important. The A cannot be equal to 0. Now, what does that do for us? Well, let's think about if the A was equal to 0. Then here I would have 0 times x squared, which would be 0, right? And I wouldn't have an x squared. So by saying that A cannot be equal to 0, we're guaranteeing that there's going to be an x squared. Class, what is it that makes a quadratic equation quadratic? The x squared. In other words, it's a second degree, just like I don't know why I wrote it again. It was written right up here, but anyway, I guess it double makes the point. It's a second degree equation. So it's different in nature than a linear equation, so we're going to have to use a different strategy for solving it. We're actually going to have 3 different strategies for solving quadratic equations. Now, if you took the beginning algebra class, you learned one of those. That's the one we're going to review today. And then in class on Thursday, we're going to look at two more. So that's where we're headed, how to solve a quadratic equation. Before we tackle that, we're going to look at something else that's going to seem like it's not related first. And so let's talk about something called the zero factor property. You've known what the zero factor property says ever since about 3rd or 4th grade, maybe even before that. You just maybe had not formally stated it. Here's what it says. If A times B is equal to 0, then one of two things has to be true. What do I mean? Yeah, one of them has to be 0. The only way you can multiply two things together and get 0 is if at least one of those two things is 0. So if A times B equals 0, that means either A is equal to 0, or it means B is equal to 0, or they're both equal to 0. If either one of them is equal to 0, then the whole thing's going to be true. A times B is going to equal 0. So the zero factor property allows me to solve equations like this. The quantity x plus 6 times the quantity 2x minus 3 is equal to 0. Here's how. Think of x plus 6 as your A. Think of 2x minus 3 as your B. So what you have here is A times B is equal to 0. Now, that will be true if either A or B is 0. Then the whole thing will be true. So, to solve it, what we do is we take our A, in this case x plus 6, set it equal to 0 and solve. And we take our B, 2x minus 3, and set it equal to 0 and solve. Because again, if either one of those two things is true, then the whole thing's going to be true. Alright, well if I solve the first one, I could subtract 6 from both sides. Get those to cancel, and x would equal negative 6. To solve the second one, we could add 3. And we'd have 2x equal to 3. And then divide by 2. So here's an equation that has two solutions. One is x equals negative 6. The other one is x equals 3/2. If you plug either one of those back into the original problem, the whole thing will hold true. If you put negative 6 in, here negative 6 plus 6 is 0, and 0 times whatever you get here would be 0. If you put the 3/2 in over here, 2 times 3/2 is 3, 3 minus 3 is 0, times whatever you would get here would still give you 0. They both work. So you might be wondering, Mr. Black, what does this have to do with quadratic equation? Well, in a moment, we're going to consider this equation. 4m squared minus 20m plus 25 is equal to 0 That's a quadratic equation because the biggest power is 2. Fits the definition. And our strategy for solving it, here's what we're going to try to do. We're going to try to make this equation look like that equation. Because if we can do that, if we can write it as something times something equals 0, then we can solve it in the same fashion that we solved this one. Okay, that's where we're headed. That's what we're trying to do. Now, the question is, how is that done? So let's call this part of our notes, let's call it solving quadratic equations by factoring. Must have something to do with factoring. And 3 little steps is going to take care of it. Step 1, we're going to get that 0 that we need. So step 1 is set the equation equal to 0. On this problem that we're going to do in just a moment, this one, that's already done. We already got a 0 over here on the right hand side, right there. So that part will be taken care of. Once we get a 0, then we're going to try to make it look like something times something. Well, golly, isn't the process of writing a polynomial of something times something, isn't that called factoring? Isn't that what we've been doing all chapter long? Step 2 is to factor. Once we get that done, then we will have what we wanted here. We'll have, our equation will look like this. X plus 6 times 2x minus 3 equals 0. It'll look like that. Something times something equal to 0. And then we'll use that 0 factor property, and the way that we did that was took each one of these factors and set them equal to 0 and solved. So our last step over here, step 3, set each factor equal to 0 and solve. So let's consider this problem again. 4m squared minus 20m plus 25 is equal to 0. Again, it's quadratic because my biggest power is 2. So, step 1, get a 0. We've already got a 0. That's done. Step 2, factor. So I got to try to factor this stuff over here, which brings us back to chapter 6. Go through our line of questions. Is there a common factor? In 4, 20, and 25, I don't see one, do you? It has 3 terms, so we'll use the AC method. We're going to leave 4m squared alone. We're going to leave 25 alone. 4 times 25 is 100. 1 times 100 and negative 1 times negative 100 would give me 100, but neither would add up to negative 20. 2 times 50 and negative 2 times negative 50 would multiply to 100, but neither one would add up to negative 20. 3 and 4 don't go into 100. Well, 4 does, 25 times. 4 and 25 are negative 4 and negative 25, but neither one of those add up to negative 20. 5 goes into 120 times. 5 times 20 or negative 5 times negative 20, but neither one of those add up to 20, negative. 6 doesn't go into 100. 7 doesn't go into 100. 8 doesn't go into 100. 9 doesn't go into 100. 10 goes into 100 10 times. And negative 10 and negative 10 add up to negative 20. That's the combo we need. Minus 10m and minus 10m. Do grouping. Out of 4m squared and 10m, we could factor out a 2 and an m, which would leave us with 2m minus 5. We'd like to be left with another 2m minus 5 in the second set of parentheses, which means we're going to have to factor out a negative because these two signs are going to have to switch. Take out a negative 5. And that'll leave 2m minus 5. So it appears to factor 2m minus 5 times 2m minus 5 equals 0. And my second step is done. I've got it factored. And now it looks like this problem that we had up here, x plus 6 times 2x minus 3 equals 0. So we can do what we did there to finish it off. We'll set each factor equal to 0 and solve. Now normally I'd set both of those equal to 0, but they're the same thing and there's no reason to do it twice. So we'll let 2m minus 5 equal 0 and solve for m. Add 5 and add 5. Those cancel. 2m is equal to 5. Divide by 2. M equals 5 halves. There you go, class. There's your solution. M is equal to 5 halves, or 2.5, or 2.5. What do you think of that? Mr. Black, I really like it. Well, good. I'm glad you enjoyed it. Let's do a couple more of them after we breathe for a second. Okay, so here's what I'd like to have happen. I'd like for you guys to coach me through this problem right here. And my first question is, why is this a quadratic? Just because z squared. Okay, so what should I do first with it?
You have to make it equal to 0.
And how am I going to accomplish that?
Subtract 25z.
Okay, couldn't have said it better myself. We got to get the 0. So let's get rid of the 25z on both sides. We could get rid of the 5z squared on both sides. That'd do the same thing. We'd just have it on the other side and the signs would look different. But so they cancel over here. Now those are not like terms, so we're not going to try to combine them. So we have 5z squared minus 25z equal to 0. That's step 1. Okay, what's step 2 going to look like? Step 2 is to factor. So what question should I be asking? Say that again.
What type of equation it is?
Well, we've already established that it's quadratic. That's why we got a 0 on the right side. We put a 0. I'm talking about to factor 5z squared minus 25z. What question should I ask myself first? That's right. Is there a common factor? That's always the first question, right? In 5z squared and 25z, is there a common factor? Yes, there is. What is it? 5z. Let's factor out a 5z. 5z out of 5z squared leaves z. 5z out of negative 25z leaves negative 5. Okay, now this time I've got 3 factors. 5, z, and z minus 5. So think of this as your A, this is your B, and this is your C. Okay, so what we'll do is we'll take each one of those and set them equal to 0 and solve. Now, if I set 5 equal to 0, that can't be true, can it? 5 doesn't equal 0. It's going to kick it out. I'll set z equal to 0, and that could be true. Z can be 0. And z minus 5 equal to 0. And then we'll solve each one of those. That one's already solved. How nice. And over here we'll add 5 to both sides. Get those to cancel. So this problem has 2 solutions. Z equals 0 and z is equal to 5. By the way, sometimes your textbook in the back, sometimes it'll write that as a solution set. It'll say that the solution is the set 0, 5. That's the same thing. So if you see that, don't be crossed up by it. This means these 2 things. Okay, now, how's our time doing? Do we want to finish the day with a hard one? A hard one?
Well, if you're going to give us one on our homework, then yes.
But maybe the best thing for me to do would not be to do a hard one, and then you do it yourself, and then when you get it right, you feel the sense of accomplishment that you did it all by yourself.
No.
Just no? That's your answer, is no? 2x plus 1 times x plus 1 is equal to 2 times 1 minus x, close the parentheses, plus 6. Your directions here are simply to solve. So you might be saying, Mr. Black, that doesn't look like a quadratic to me. Well, right now you're right. It doesn't look a whole lot like a quadratic because right now we don't see any x squareds. But remember, a quadratic is defined to be any equation that can be written as ax squared plus bx plus c. Doesn't mean it has to be. Right now this doesn't look like a quadratic, but we're going to see that it's going to be. We're going to multiply these 2 things together, and when we do that, we'll get our x squared. Okay, now look, let's pause for a minute. Let's pause for a second. If the right side over here said 0, then I would be ready to set each one of these factors equal to 0 and solve, wouldn't I? But I can't do that until I get a 0 on the one side by itself, and I don't have that here. So that's the key to us knowing we got to multiply this stuff out. So here we go. 2x times x is 2x squared. 2x times 1 is 2x. Done with the 2x. Let's distribute the 1. 1 times x is x. 1 times 1 is 1. Done with the 1, done distributing. Over here, if we distribute the 2, 2 times 1 is 2. 2 times negative x is negative 2x. And then we still got plus 6. Okay, let's clean both sides up a little bit by combining some like terms before we do much else. So we have 2x squared. 2x plus x is 3x plus 1 is equal to, and over here we can combine the 2 and the 6 and get 8 minus 2x. And now it does look like a lot of the other equations we've had. It's got an x squared in it, so it's quadratic. Since it's quadratic, we need to get a 0 on one side. I'm going to get a 0 on the right side. Now watch this. To do that, I got to get rid of this minus 2x. So I'm going to add 2x. So since that's like 3x, I'm going to put it underneath there. That'll make it easy for me in a moment.
What is that again? Underneath the 2x?
Okay, I need to get a 0 over here on this right-hand side of the equation over here. So I got to get rid of minus 2x, so I'm going to add 2x. So when I add it on the left side, I'm going to put it underneath the term that it's like, just to make it a little nicer and cleaner for me in just a moment. So it's like the 3x, so I put it under there. Similarly, when I subtract 8 to get rid of it on the right side, when I subtract 8 on the left side, let's put it under its like term. Well, it's like positive 1 because it's a constant. Now you wouldn't have to do that, but that just makes it a little nicer, a little cleaner for us. So now the right side, everything cancels, and there's our 0. That's what we were after. And on the left side, I've got 2x squared plus 5x minus 7. And we got our 0. That's step 1, remember? Step 2 is to factor. Okay, so I'm not going to worry about all this stuff that I've done up here already. Right now it's not important to me. What's important is this. So I'm going to move that up. So let's look for a common factor. Well, in 2, 5, and 7, there isn't one. It's got 3 terms, so we'll do the AC method. So bring 2x squared down, or bring minus 7 down. It's the same old song and dance we've done about 6 trillion times now. 2 times negative 7 is negative 14. Factor pairs for negative 14 would be like 1 and negative 14, or negative 1 and 14, neither of which add up to 5. But 2 goes into 14 7 times. 2 and negative 7 are negative 2 and 7. And negative 2 and 7 do add up to 5. That's what I need. We go negative 2x plus 7x. And we shall do some grouping now. We can factor 2x out of those first 2 terms. 2x out of 2x squared leaves x. 2x out of 2x leaves 1. Take a 7 out of the last 2. 7 out of 7x leaves x. 7 out of negative 7 leaves negative 1. So we have a factor of x minus 1 and a factor of 2x plus 7. And step 2 is done. We got it factored. Step 3, take each factor, set it equal to 0, and solve. So x minus 1 equals 0. 2x plus 7 equals 0. Add 1, and we get x equal to 1. Subtract 7, get 2x equal to negative 7, and divide by 2. And x equals negative 7 halves. And there are your two solutions, 1 and negative 7 halves. Hey, class, check out that problem. I mean, we're getting halfway sophisticated with our algebra these days. And the problems are getting longer. So, cool. Now, don't lose sight of the beauty of algebra for a moment. Even if you don't love it, maybe you can appreciate it a little more if you just think this way. We were looking for the value of x that made this statement true. And what we did was, if that statement was true, this statement had to be true, which made that statement true, which made that statement true. And we just used deductive reasoning all the way down until we ended up with these two conclusions. It didn't take us that long, maybe 8, 9 steps, whatever. If we didn't exercise the logic in the fashion we did, how long would it take us to guess what values I need to put in here for x to make the left side equal to the right side? I mean, you might guess 1 fairly quickly, but how long is it going to take you to guess negative 7 halves? Probably a while. So that's part of the beauty of algebra. It allows us to figure things out fairly quickly by just using some reasoning, that's all. That's what algebra is an exercise in logic. Okay, I pause for a second. Here's what I think you should do for your assignment. It's page 350, 9 through 37, and I would work on the odds.